Welcome, everyone. My name is Meryl Witteveen. I'm a product director at C3 IoT. Quick show of hands to get out of the post-lunch coma. Who knows about C3 IoT? All right, that's about 5%. Let's make that 100 at the end of this session. At C3 IoT, we've been involved over the last 8 years to develop a platform as a service that enables organizations to design, operate, and build AI and IoT enterprise applications at scale. Today, I would like to describe to you the journey that we've taken together with our customers, and I would like to give you a little bit of a sneak peek of a new product that we've been working on. So when we talk about what we do at C3, we really mean AI at enterprise scale. Now, I'll run you through some use cases to have a look in a second. Today is a very interesting point in time. There is a convergence taking place of 4 very important vectors in the IT space. The first one is cloud computing. And I don't think I need to comment on that any further. You're all here. The second one is AI and machine learning, or the rebirth or re-emergence of AI and machine learning. New and faster computers allow us to run through algorithms that we couldn't run before. Next, we have IoT. And the way we view IoT is the full sensoring of the entire value chain. So for instance, take the electricity grid. The electricity grid is sensored all the way from a little pump in a generation plant to the sensor in your home telling you whether the light switch is on or off. And this whole sensored value chain provides tremendous value when you can contextualize it all. And then the fourth vector we see is big data. Now, big data has been around for a while. And one of the easy implications, or one of the ways we look at it, is truly we use all the data that is available to us. So not just the data that is stored in a database. So an implication of big data is that you no longer have to worry about your 101 statistics course, whether you have a sampling bias, you try to run an algorithm or not. That's no longer the case. But what's exciting about this is that big data allows you to see every bit of data going through your enterprise and really understanding what's going on at any point in time. Now, imagine what is possible if these 4 vectors come together and work together seamlessly in one experience. That would truly change the way you do business. And that is what we call a digital transformation. C3 IoT enables organizations and encourages organizations to go through this digital transformation. And we help organizations to gain economic benefits and social benefits out of these transformations. We have customers in healthcare, in manufacturing, in the electricity grid, and I'll run you through some use cases. Now, a digital transformation is different in any industry. And often in discrete manufacturing, digital transformation comes to life in predictive maintenance. And what we mean with predictive maintenance is that you have a true and accurate overview of all your equipment at any point in time. And with that, I don't mean just whether a certain asset is switched on or off, but also understand who maintained this asset prior, what was the order that was fulfilled, and how long has it been running? Were there any notes taken by the last maintenance person? And what this allows you to do is it allows you to forecast whether certain assets will fail in the next month or so. And it allows you to get to these assets before they fail, which of course is hugely valuable, that you don't have to shut down an entire plant in order to fix a certain asset, but that you can maintain it before it happening. We have done successful predictive maintenance applications for a number of different assets and industries. We've done it for rotating equipment, like water pumps, but also for network topologies, For instance, we can forecast whether a certain part of the electricity grid will fail and people will be in the dark for a number of days before it will actually happen. We've also looked at static transformers, and we're currently in the process of deploying maintenance for the US Air Force. We've also done a lighter version for humans. Can you predict whether a human being will develop diabetes in the next 5 to 10 years or not, and treat that before it actually happens? Now, in all of these cases, what C3 IoT does is it brings together data scientists and developers to work together on these applications and to develop these applications quickly. Our typical applications take about 6 to 12 weeks to develop and run accuracy scores 70, 80 to 90%. And we deploy them throughout entire organizations that give everybody in the organization access to the same data set. Another area in which we're very active is the oil industry. Some of our customers are named, others are not. One of them that is very interesting is Origin Energy. It is an oil and gas company from Australia. And the way we started with them was they had about 3,000 oil wells. And they had equipment running on these oil wells. And they wanted to know what piece of equipment do we have to replace in a certain pump to this pump can run for a much longer period of time. And the interesting thing about Origin was that it started out as a small trial. Then they deployed this actual application that I just mentioned. And now they're in the process of deploying our platform, and they're having their own developers and data scientists develop applications that are suitable for their own use cases and their own specific needs. And that is always a goal that we have at C3 IoT. We want our customers to develop their own applications and to be efficient. The smart grid is where it all started for us. Enel was one of our first customers, and I'll briefly mention a little bit about them. They're the biggest utility in Europe. They are active in over 40 countries. They have over 60 million customers, so they're an enormous utility. I believe only the state grid in China is bigger. And the data size that currently runs on the C3 IoT platform is approaching 1 petabyte of data. Well, that's tremendous volumes. And it grows by 300 gigabytes every single day. Now, every day we make about 8 million predictions in a variety of applications that is currently deployed throughout their organizations, from predicting whether certain meters, like electricity meters, will fail, predicting whether certain people are stealing electricity from certain houses, predicting whether a customer will churn, and whether a piece of equipment or network equipment will fail. So it's a variety of things that we do for them. We're seeing a lot of traction in smart cities at the moment. There's certainly some fascinating use cases that we can address here, but in the interest of time, I'll skip this one for today. But you can imagine all the things you can do in smart cities. As I briefly mentioned earlier, healthcare analytics. Can we predict that someone will develop diabetes in the next 5 to 10 years? What you currently see in the healthcare space is that many healthcare companies try to predict this with rule-based algorithms. For instance, if your blood pressure is above a certain value, if your glucose levels are above a certain value, and if your BMI is also above a certain value, you're likely to develop diabetes. But what is much more accurate, if you can actually get all the data and actual true positives of an entire population and include many more variables and develop a machine learning model to actually forecast whether someone will develop diabetes. So we did we have a customer who built their own application leveraging the C3 IoT platform, predicting whether certain people are going to be dependent on opioids, which is, of course, a very fascinating and current problem today. And what they were able to do is they were able to load all their patient data. They were able to load all the hospital data, clinical data, pharmaceutical data, of a population of 125 million customers. And they were able to do this in 9 weeks and got a precision of 78%. The accuracy was 78%. Before they used our platform, they tried to do this themselves, and they didn't succeed for 2 years. So this was a major victory. Now, an obvious next candidate, after going over healthcare and manufacturing, is CRM. And what we see is that our platform is very useful for challenges that ERP vendors and customers are facing. So what the C3 IoT platform lets you do, it lets you connect to all the data sources. So not just your CRM system, but actually it lets you connect to your vendor systems. And what that allows you to do is that you can give your customers very accurate predictions of when equipment will ship or when it will arrive, instead of just guessing and trying to keep customers happy in an awkward way. Now, another interesting use case that we could discuss is autonomous vehicles. We're based in the Bay Area, and we see these driving around all the time, and it doesn't take a lot of imagination to think about all the use cases that we could go through for this particular case. So I'll leave this to your imagination. So I briefly mentioned earlier that we've currently deployed our predictive maintenance solution for the US Air Force for their F-16s and their E3 AWACS. And E3 AWACS are these planes, you probably recognize them, they have a little shuttle on the top. And what we saw after we rolled out and after we announced this is that we're getting a lot of inquiries to roll out predictive analytics in the aerospace industry for several other large companies to truly predict up to the subsystem within a plane whether a failure is going to take place. This, of course, has tremendous economic benefits if you can forecast whether something will fail when it's still arriving at a certain airport, and you can have your scheduling crew or your maintenance crew ready to know which area they have to address. And last but not least, supply chain optimization. It's a very interesting challenge that we're facing here. It's what we call stochastic inventory optimization. What that means is, what is the ideal level of inventory you want to hold in order to prevent that you will run out of inventory and will actually have to stop your production, but that you also save costs on your inventory. So we deployed an application for a very large discrete manufacturer. They have a revenue of about $40 billion a year. Their inventory costs are $6 billion. So huge numbers. And we started small, and we found that for one particular machine, we were able to reduce inventory costs between 30 and 50%. And we're currently rolling this out for all their factories worldwide. Hopefully, the overview I gave you gives you a good idea of the projects that we do at C3 IoT. And in all of these cases, what we want to do is help our customers get to the point where they can use our platform sufficiently or self-sufficiently so that they can create their own applications and focus on their unique use cases. Now, let us take a little bit of a detour and look at why we can do this in such a short time frame. And to do that, I would like to introduce to you Riley Siebel. He's a software architect at C3 IoT. All right.
Thanks, Meryl. Thank you, Meryl. So let's talk about how we architected our platform to enable these companies to build this diverse set of applications in the short periods of time that I mentioned, like 6 to 12 weeks to build and deploy an enterprise-wide application with predictive analytics. What sort of components do you need when you're going to build an application that looks like this? You're basically going to need one of everything, right? You need a relational database, you need a non-relational database, you need a persistent queue, you need a non-persistent queue, you need elastic scaling, you need AI systems, you need in-memory caching, you need in-memory analytics. I mean, the list just goes on and on and on. All right. So what happens most of the time when some company tries to put together all the pieces that they need to build this application, right? You go to the open source Hadoop stack, and you pick your favorite of all the different things. And then you try to make them all talk to each other. And it is just hard. You need to find an expert in each individual one, because they're all developed by different people with different philosophies, different APIs. They produce data in different ways. And you need to figure out basically how to get all these different things to connect to each other. And especially as your application starts to get more and more complicated, you need to build more and more connections, and it just kind of fails to scale. So as you're adding more and more things, they need to start talking to each other. And if you have n components, this looks like an n to the n problem. And as you add more components and more complexity, it just gets harder and harder and harder. All right, so we did not do that. Instead, we built what we call the C3 type system, which is the foundational technology of our platform. And it's the intermediary through which all of these infrastructure components interact. And not only the infrastructure components are interacting through this single medium, but also the application developers and the applications themselves, as well as data scientists and operations people, are all using this same single abstraction layer to deal with infrastructure of all kinds. Just a quick aside as an example, that means if you want to switch an Oracle database and put Postgres in, all the applications just keep working, because there's no application that knows anything about any Oracle or Postgres database, just as an example. So we built a platform on this philosophy, and this is kind of a more detailed overview of it. It consists of a couple major pieces. The first thing is a data integration layer. We are an IoT company, and you need to get data from a lot of different sources. That includes IoT data, but you also need contextual data from weather system, GIS data, as well as your ERP systems. Anything you've got running in your business, you need all of it to make the best answer. And so we have a data integration solution to get those data into the platform, or to connect to your existing data stores and treat them as if they were in the platform. Then we have a bunch of platform services for things like security, data federation, so querying across multiple databases, stream processing, batch processing, ways to bring libraries from external systems that you like. You know, if you want scikit-learn in your platform to do something, great. Then we have UI services to help you build the actual end experience that people are going to use when they're consuming the results of your application. And on top of that platform is how we've built all of our applications and how our customers build all of their own applications as well. And today we're really excited to be announcing C3 Orion, which I would like Meryl to help talk to you guys about.
So C3 Orion is really a way to bring the C3 IoT platform in the hands of individual developers and data scientists. So C3 Orion lets you build AI and IoT applications at scale. Can go to the next one. It lets you operate these AI and IoT applications. And we've integrated a full learning experience all in the same tool. So let's take a look at these individual items in a little more detail. So first of all, building AI and IoT applications. What needs to happen? Well, we have a suite of visual development tools, truly for the end-to-end process.
And in those visual development tools, you can manage the full process. And the visual development tools are all writing code that looks like the code you would write if you were using IDEs.
But at the same time, you can also use an IDE or command line tools if you prefer.
We want to support a full range of developers, from less experienced people, more business intelligence style users, all the way through to your expert data scientists who want to get down to more the bare level and choosing the individual libraries and versions of libraries that they want to use.
And what that means is that at any point in time, you can just switch between visual tools or the command line tools and IDEs.
Yeah, and you can deploy from either way and collaborate between developers who are using their more formal IDE and command line tool technologies and the visual development tools. And the Orion,
So to operate these AI and IoT applications, it's very important to have good source control. You need to have DevOps, and you need to be able to monitor your environments. So we've integrated, again, all these tools in one seamless experience.
Basically, anything that you write, whether in an IDE or through the visual tool, automatically causes a continuous integration process to kick off, running all your tests and producing deployable builds that are known to be working.
And we have integrated a full model management systems for all your AI and machine learning models.
You need to make sure, if you have lots of different versions of your model, perhaps with different hyperparameter values, you need to pick the best one, track its performance over time, and switch them out in production live as you produce new and better AI systems so that you can make sure your application, for example, doesn't lose performance over time.
So Orion allows you to build AI and IoT applications. It allows you to operate these applications, but it also has integrated a full online learning experience. So the learning curve is really fast, and people are up to speed in a matter of days.
Yep, this includes a full Stack Overflow-like experience where the existing C3 developers, both who work for C3 and who don't, are collaborating every day to answer each other's questions, as well as fully integrated documentation that's generated from the code, as well as tutorials that we've written that include video tutorials and text-based tutorials for people to follow to learn about stuff.
Now, this all sounds great, but seeing is believing. So let's take an actual look. And for the purpose of this demo, we created an application that predicts failures in light bulbs. So what this application lets me do is, this application uses machine learning, analytics, and over 3 million rows of data to forecast whether there will be a light bulb failure somewhere where we have our light bulbs located.
So what we're seeing right now is we're seeing the developer homepage where you can see I've got one application that I've been building. It's called Light Bulb Predictive Maintenance, and let's check it out. When I click this button, I'm in my own instance of this application, which has its own URL, and its own GitHub branch was created in the background. So everything I do through this tool is writing to GitHub, which allows anybody who wants to use an IDE to just check out that branch and start collaborating.
Before we dive into any deeper, let's take a look at the actual end application that this is. So this application is pretty simple. On the left-hand side, it has a filter panel. And the right-hand side is rendering, because everything is live, as we're showing this to you. But on the top, it shows a graph with, we're here. On the top, it's going to be a graph. In the middle, we have a map with all our locations of our light bulbs. And we've indicated them in green and red light bulbs. The red light bulbs mean that they're at risk. And we've developed a risk score, and we said if the risk score is larger than 50%, make them red. The green light bulbs are not at risk. On the top, we have a histogram showing the number of light bulbs by risk score. So for instance, there are about 18 light bulbs with a risk score between 10 to 20%. And last but not least, the third component on the bottom is a grid displaying each individual light bulb and their risk score. So this is the application that we're going to build, and we're going to run you through the process of showing you how easy it is.
So as I mentioned before, I'm in my own instance of this application, building it and writing code. And the things that I need to do to build an application are?
I need to create a data model. And in C3, we create a data model by creating C3 types. I need to integrate and explore the data that I have available. I then analyze my time series. I create a machine learning model, and I develop a UI. So it's pretty simple. Let's take a look.
So the first thing you're going to want to do is build your data model. In this case, there are a few types that are relevant for understanding this application. The first obvious one is the smart bulb itself. So when I look at the smart bulb type, I can see that it has some fields. Those fields themselves have types. And there's no notion of this being persisted anywhere in particular. In this particular case, this guy is persisted in Postgres, but I don't know that necessarily as a developer unless I want to jump into the advanced options and configure persistence. Some of the fields on this type are actually stored in Cassandra. So when I fetch this object, it does a federated data query and pulls data from Cassandra and Postgres, shoves it back together, and gives it to the UI as a JSON object. I can do the standard things like add a field. Maybe this one's a decimal, and it's called my new field, whatever. And this will create a new column in the database if this is in a Postgres table, or the relevant equivalent in whatever database it is that we're talking about here. I also can add methods to any type at any time. And when I add methods, one of the cool things I can do is choose what language to implement it in. If I choose, and any function written in any language is automatically callable from any other language through the type system. If you have questions about how that works, I'd be happy to talk to you about it later. The other types you'll have to know about to understand the application are smart bulb measurement. So this represents a single measurement at a point in time, in this case of power output and brightness of the light bulb. I also have smart bulb event. These represent things that happen sort of sparsely in time. For example, lightning strikes, someone switches the switch on and off, those sorts of things. They're also arranged in time, but with very, very many fewer of them. And then the output of my machine learning model itself goes into the, by the way, I'm seeing the relationships between these types here. So the smart bulb prediction itself is also an element of the data model, and it's the output of the machine learning model, which gets stored somewhere. And I use that type for rendering in the UI and things like that. And the last type I want to show you, just because it's interesting, is actually this transform type.
So now that we have created our data model, it's time to load some data. And at C3, we load data through an abstraction layer. And our abstraction layer consists of 2 additional types. So they're identical to the types we've just defined in the way you define them. The first layer is a canonical type. And in our case, a canonical type accepts the data in its incoming format. And the second kind of type is a transform type. And that is the type that Riley just shows you. And it transforms the data from the canonical type to our actual data model type. So in this case, we've got that in our data model here as well. So for the purpose of this demo, we preloaded some data. But loading data is very straightforward, and we've done it in advance here. So we're looking at the data monitor tab here. And as you can see, I've loaded 3 data files. And what C3 Orion did is it automatically batched these data files, and it's processed them, and it transferred them, and they're ready, and I can view them right now. So what we see here is my first file, the smart bulb file, was processed in 1 batch. The second one was over 338 batches, or was 338 batches, and the third one in 78. Now, once I've loaded data, so I created my data model and I loaded my data, I can actually explore the data that we have. So take a look.
These are all the fields on the smart bulb. I could just add more fields that I want to look at and view all the data here. And just by the way, as an aside, we just happen to be using files in this demo, but any data transport layer that looks like a named columnar data store or JSON data store or anything like that can be transformed using the same technology. So once we've built our data model, loaded all the data, the next thing we want to do is we want to do some time series analysis to figure out what's going on over time as it relates to our smart bulbs. And so for that, we have a tool. And let's look at all of the time series transformations that are relevant to the smart bulb type. We have some standard ones. For example, average power. You'll notice there's no JavaScript or Python code or anything like that during these time series transformations. That's really interesting because it allows these things to be nested and automatically recomputed when data which invalidates this expression arrives. That itself is another very long topic that I would love to go into later, but I don't have time this moment. So let's check out what happens when I evaluate this. We're going to evaluate this metric, this time series analysis on 1 year's worth of data. We would like to see it at a daily interval, and we'll just chart it. So here we're looking at all the data from this smart bulb having been evaluated through this expression from 2011 to 2013, so 2 years of data at a 1-day interval. We can just check out this data and see what's going on. One of the interesting things about the way we do transformations is there's no notion of time in the transformation itself, so I can just come in and say, actually, month is what I care about, and there's the data at a monthly interval. So these get built up into arbitrarily complex transformations. And another one that I'm interested in showing you, because this is the one we're going to train on later is defective, right? So we need past examples of failure to predict future examples of failure. This time series transformation is the one which is basically our true positive label set, all right? And you can see the rule here is pretty readable. It says look over every hour. If the lumens was 0, meaning it didn't produce any light, but the status is 1, meaning it was switched on, then it was broken, right? So that's the rule for is it broken. And this thing decomposes into less and less complex transformations. For example, average lumens is very similar to that average power transformation that I showed you earlier. And status is a very similar one, but it operates on the sparse data, not the continuous data, because we're looking at switching events. So once I've done my time series transformation, the next thing I want to do is I want to train a machine learning model, use it to predict future failure, and take those future failures and put them back into the application so I can show a UI. So there's a couple tools integrated into Orion for doing this task. Oh, I forgot the VPN. So first I'll show you the other one. So the first one is we have fully integrated Jupyter Notebook, which allows developers to access all the same data objects and APIs that we wrote in the other application. And here we can see I've done a little notebook, which has, in this particular case, a nice little tutorial about how to build a smart bulb prediction using Jupyter. And you can see here that I can do things with types that, for example, the light bulb type, I can look at its metadata right here in Jupyter Notebook, or maybe I can fetch all my smart bulbs. So smartbulb.fetch is an API which goes against the server, can be executed in any language, JavaScript or in this case Python, and I get results back in the correct format. So in Jupyter Notebook, I get them back as instances of Python classes which represent these types. So here I have a bunch of C3.smartbulb classes. And did we make it on the VPN? Great. The other one is Ex Machina. And Ex Machina is a sort of little bit more basic tool. It's a visual drag and drop interface for performing the same kind of tasks. So in this case, I've built a machine learning pipeline to do prediction of failure in light bulbs. So first of all, there's a lot of things you can do with this tool. You can pull data from a lot of sources, including C3, if you have an external HDFS instance that you haven't yet integrated to the platform, or any other sort of data source. You can build your own analytics right here in the pipeline, including a huge library of expressions that we built, and data preparation tools, flatten time series, split stuff, do whatever, and a bunch of machine learning models, algorithms actually, built straight in here. Just pick some examples. Here we have a PCA, random forest prediction, k-means, gradient boosted decision trees, good selection of stuff in here, and we're always adding more. You can also just write your own custom code in here if you want to build a cool node. That's not here. You can output this data back into C3 or currently into SAP HANA. And there are also some actions you can take, like sending emails, basically firing alerts, right, when things happen. So let's look at this specific pipeline, which is going to use those time series transformations we built earlier in order to predict that is defective label in the future. So the first thing is I say I'm looking at smart bulbs. The signals that I find to be predictive are the duration the light bulb's been on, how many times it's been switched in the previous week, and will it fail next month is actually a transformation of is defective that looks in the future. So will fail next month is true when is defective is true anytime in the next month. And has it ever failed? Because if it's ever failed, that's like highly predictive of failure, right? So fine, let's evaluate all those for 6 years at a daily interval. So we'll produce a 6-year-long time series for all the smart bulbs for all of those signals. Now we start to get into the machine learning stuff. In this case, for people who know about machine learning, this is going to look very familiar, and for some other of you, I'm happy to explain it later. Basically, we're going to split our set into a training set and a validation set. We're going to do some time series flattening to get nice, clean data. Then we're going to train our logistic regression, in this case, model. And here we have some parameters we can set, however we like to do them. And then we will predict with that model what's going on in the future. And so I'll just run that. Oh, no. I killed it.
Well, as the model is running, we can...
There we go.
Oh, there we go.
So here we can see some analysis of the output of this machine learning pipeline. So very many of the smart bulbs look like they're not going to fail. Very few of the smart bulbs look like they have a very high probability of failure, and there's kind of a distribution in between. We can also look at the distributions of the individual signals that were used at the input to this transformation, and we can do some other clustering and exploration of the output of our machine learning model to verify that we built one that works, right? So fine, we built one that works, then we output the data back into C3, and the next step is to build a UI.
So now that we've created a data model, we loaded our data, we analyzed our time series, and created a machine learning model, and pushed these outputs of the machine learning model back to C3, we can start building a UI. And for this demo, we've pre-built the UI, but we will change a couple of components to show how easy it is to make changes or to add new components. And for instance, we have our top histogram currently has 10 bars. Let's make that 5. So what you do is, all you do is you just select the components, and it gives you a whole bunch of options that you can modify. So here we have the number of bins is selected at 10, but we can make it 5. So let's make it 5. And what it will do is it will recalculate. Let's try again. It will recalculate these bins, and it will show you them in 5 intervals. Oh, we just saw it.
There we go.
There they are. So you can also add a new component. So at the bottom, we still have some space left for a new component. So let's scroll there. So let's say you want to add another grid component. I can just grab the grid component there and drag it into my workspace. And let's say in this grid, I want to show the predictions of my light bulbs, and I want to show the latitude and longitude of where they're located. So all you do is you just drag that grid component in, select prediction, and select the other items that you want to display. So in this case, latitude and longitude. And it will do the recalculations, and it will show up. So there it is.
There's our grid. Great, so we built a data model, including data from source systems and outputs of our machine learning model. We did time series transformation to find out how we're going to take that data and essentially enrich our data model. We built a machine learning algorithm, which is going to predict failure. Then we showed all of that information in a UI, which is customizable on the fly. And we've built an application. We're done. Well, that was the build part, but we also mentioned operate. So presumably, the idea here is you have some large enterprise, a large team of people, everyone needs to collaborate, and so we have a full suite of integrated tools to allow just that. In particular, I mentioned that a GitHub branch was created for me when I created this application, so everything I've been doing is writing to this GitHub branch for me, and I can create a pull request right through to master. When I do that, all the tests are going to be run, and I can view the historical of those tests right here in this application. In this case, I just have the one package, and I don't tend to write failing tests in demos, so everything looks good. Finally, I need to take this tested and built application and deploy it through to maybe staging environment, QA, however your process is at your organization. And so I have a deploy tab where I come down, I see all the versions of all the builds that have ever been built. I can click through, and this doesn't have any changes, but you would see all the changes that have happened since the previous build, and certain users can be authorized to deploy things. So for example, come right here, deploy this to staging environment. Each organization can configure their own topology of environments. So maybe you have staging, QA1, QA2, and production, and you can go from staging to QA1, QA1 to QA2, or staging to QA2, and QA2 to production. Whatever the topology is that you guys want to use, we support it through this tool.
So once you've deployed your application, it's obviously nice to be able to manage it. So we've created also a whole suite of tools that allows you to manage the queues, cron jobs, and environments. Let's take a look. So here we're looking at our work queues, and we can see all of them. But what probably is a little more fun to see is let's look at environment performance. So here we see, in this case, I've got 2 master nodes running and 4 workers. And I can, on the fly right here, change the number of masters and workers. I can turn on and off auto-scaling. all right here. I can create cron jobs in a different tool. All that will be written directly back to the C3 platform.
Right. So to bring it all together, I mentioned that this is all writing code, right? This is not some XML file living somewhere, although some of it is JSON. But it is all writing code somewhere. So for some people, they want to use the code. They want a code-based interface, okay? And so this is a browser-based interface that allows users to execute JavaScript against the platform through the type system. So for example, I can run the type smart bulb, the method fetch with no arguments. The type system client library will turn this into a REST API call, which executes against the server, pulls some data from multiple databases, gives it back, shows it here in a grid, and here's all my data. It's interesting to note that you can see how these get turned into REST API calls automatically. So every action on every type is automatically exposed through a REST API in a consistent format. That's how the UI works. That's how the visual tool for developing works. That is built using the type system. We built it using itself. And so everything is fully REST API compliant, and you can get deep into the code, as deep as you'd like to go.
So we built an application. We saw how we can operate it. But we've also integrated a full set of learning tools, a whole set of integrated learning tools. So the first thing we have is we've exposed all our documentation through this similar tool. So for instance, there's a whole set of tutorials. So let's take a look at the MapReduce tutorial. It straight away populates, and there's a whole bunch of for you to get started. A second thing what we have is we have a Stack Overflow-like community. It's an online community that lets you leverage all the C3 knowledge that currently exists and allows you to ask and answer any questions. The community is very active. We currently have hundreds of C3 developers on there. And last but not least, we have a learning portal that contains over 8 hours of actual online lectures that you can follow at your own pace to really get up to speed and to figure out the best practices for C3.
So I signed up for a couple courses, and we can see what those look like. Oh, maybe not. Meryl, do you know your password? Nailed it, first try. So here we have, for example, some courses, C3 IoT 101 course bundle, which includes several classes, and let's go see what I've got going on. I've signed up for these classes, and we can see the C3 IoT 101 course bundle has some overviews, part 1, part 2, part 5, and as you get into more and more advanced classes for data scientists or things like that, you get knowledge both about generic subjects, like what is MapReduce, how does natural language processing work, and also how those work in C3.
So C3 Orion lets you build, operate AI and IoT applications, and it has a whole suite of integrated learning right into the tool. Now, we plan to launch this wonderful tool in the spring of 2018, but currently we are open for beta applications.
So what does that mean? We want you to go to orion.c3iot.com. We want you to apply to the beta. Okay, we're going to take some small number of teams, call it 10, and they're going to get free access to Orion as well as all the underlying AWS infrastructure components, right? That means AWS IoT, RDS, DynamoDB, Kinesis, all the things. And that'll be free for 3 months, and we are looking for teams with exciting use cases, lots of data, and use cases that matter. So please come to orion.c3iot.com to learn more about the product. Join the beta to get access to the C3 IoT platform starting in the spring, as well as all the underlying components. And we look really forward to seeing what all of you are going to build on our platform.
Thank you.
So we have about 15 minutes. If anyone has any questions, we're happy to answer them. If you raise your hand, we can take a question. Yeah, please, right in front.
When you're doing your hypothesis, do you actually put out the regression analysis hypothesis so that way you could use subject matter expertise to modify some of the components instead of just relying on machine learning to provide the information?
So for example, do you mean, the way I would say you can do that is to get your subject matter expertise into the machine learning model. Yeah, the question is, how do I get my subject matter expertise into the model, essentially, right? So the way that I think we would do that, and I am not actually a machine learning expert, but the way that I think we've done that in the past is you build signals which are true when the subject matter thinks the thing should fail. So you build signals to the machine learning model which are highly predictive of failure. So an example of that would be that in rod pumps, which are oil wells, there's what's called a force curve. So as you pull oil out and then push gas back in, there's a resistance depending on the position of the rod pump. And the oil company basically came to us, Origin in this case, and said, we know that that happens when the curve looks like this. We think it happens. You know, we're very sure that's predictive. So they built a signal which was true when the force curve looked like that, right? So take some period of time, make sure the force has the pattern you're looking for. If the force has the pattern you're looking for, then the signal is true. And we use that to feed as an input to the machine learning model. And you can build as many of those transformations as you want, and feed as many of them in as you'd like.
Any other questions?
Okay, well, thank you guys so much for your time, and
Thank you.
appreciate it.